Hello, my dear students. Myself, Devi Prasad Sir, welcomes to you all to this chemistry class. In this video, you will be learning the rest part of the chapter Language of Chemistry. Chemical equation. A chemical equation is the symbolic representation of a chemical reaction using the symbols and formulae of the substances involved in the reaction. Burning of coal in air is a chemical reaction in which a new substance, carbon dioxide, is formed. The reaction can be represented by either a word equation or a chemical equation using formulae and symbols. Now, the steps involved in writing chemical equation. Number 1. Write the symbols or the formulae of the reactants on the left hand side with a positive sign between them. Second one, write the symbols or the formulae of the products on the right hand side with a positive sign between them. Third one, put the sign if the arrow in between the reactant side and the product side. Then fourth one, represent the reactants and the products in their molecular form. Next, chemical reactions may involve one reactant and two or more products. Second one, two reactants and one product. Third one, two reactants and two products. And the fourth one, two reactants and three or more products. Now, balanced equation. It is an equation in which the total number of atoms of each element in the reactant on the left side of the equation is the same as the number of atoms in the products formed on the right side of the equation. An equation must be balanced in order to comply with the law of conservation of matter, which states that matter is neither created nor destroyed in the course of a chemical reaction. An unbalanced equation would imply that atoms have been created nor destroyed. Now, the limitations of a chemical equation. A chemical equation does not tell us about the following informations. Number 1, the physical state of the reactants and the products, that is whether the substances are solid, liquid or gas. Second one, the time taken for the completion of the reaction cannot be known. Third one, whether heat is given out or absorbed during the reaction cannot be known. Fourth one, the respective concentrations of the reactants and the products also cannot be known. Fifth one, the rate at which the reaction proceeds. Sixth one, whether the reaction is reversible or irreversible. Then the seventh one, whether the reaction is completed or it is not completed cannot be known. Now, atoms being extremely small cannot be seen or weighted directly, but indirect methods of physics have enabled us to know the absolute mass of nearly all kinds of atoms. It is therefore been considered appropriate to use the mass of some standard atom as a unit and then relate masses of other atoms are thus known as relative atomic mass or atomic weight. In the beginning, the mass of the hydrogen atom was chosen as a unit and masses of other atoms were compared with it. In the year 1961, carbon 12 was finally selected because its adoption least affected the values of the atomic mass of the various elements on the old standard. Atomic mass is expressed in atomic mass units. Atomic mass unit is defined as 1/12 the mass of carbon atom C12. Therefore, the mass of hydrogen atom is 1 AMU. AMU stands for atomic mass unit, and those of oxygen and helium are 16 AMU and 4 AMU respectively. The relative molecular mass of an element or a compound is the number that represents how many times one molecule of the substance is heavier than 1/12 of the mass of an atom of carbon 12. The molecular mass of a substance is the sum of the atomic masses of the constituent atoms present in one molecule of that substance. Now, the percentage composition of a compound is the percentage by weight of each element present in it. The total percentage of a compound is always 100. Now, the law of conservation of mass can also be stated as follows. It states that mass can neither be created nor destroyed in a chemical reaction or in a physical change. Now, reversible reactions. If a reaction proceeds in both the forward and backward directions, it is called a reversible reaction. Now, the balanced equation shows that every molecule of oxygen reacts with two molecules of hydrogen to form two molecules of water. In the previous lesson, you saw that an atom of oxygen needs an electron each from two atoms of hydrogen to complete its octet configuration. In a molecule of oxygen, there are two atoms of oxygen. Each atom requires electrons from two atoms of hydrogen. Hence, one molecule of oxygen needs two molecules of hydrogen to form two molecules of water. Now, the formation of carbon dioxide is written as follows, that is, carbon plus oxygen gives rise to carbon dioxide. My dear students, I hope that you all understood the contents of this video. Thank you for watching and learning from this video.